Welcome to Kitek Technologies Private Limited. This is the demo of fiber optic trainer kit ACT-12. This trainer kit consists of different blocks. The first is power supply block. This trainer has inbuilt power supply of plus 5 volt, plus 12 and minus 12 volt. Then we have function generator block. It has two output, square wave output and sine wave output. For amplitude adjustment and frequency adjustment, variable potentiometer is given. For sine wave, the amplitude and frequency can be adjusted with the help of these two potentiometer. And for square wave, the amplitude is fixed and frequency can be adjusted with the help of potentiometer. One switch SW1 is given for frequency selection from the range of 10 Hz to 10 kHz. Switch SW2 is given to select the link in analog or digital. When the switch is pressed, it indicates analog link. When the switch is unpressed, it indicates digital link. We have one F4 transmitter of 660 nanometer wavelength and one F4 receiver photodetector of the same wavelength. We have one AC amplifier and one low pass filter of cutoff frequency 3.4 kHz. One comparator. For PC to PC communication, we have two numbers of RS-232 trans receiver which can be used for PC communication in digital link. And for voice communication through fiber optic, we have audio input block which takes the mic as input and audio output block which has speaker. We can connect the speaker at the output of this. With this trainer, we provide standard accessories of 1 meter fiber optic cable, two numbers of RS-232 serial cable, set of patch cords, set of speaker and mic for audio communication, set of mandrel and NS zig and NS scale for measurement of winding loss and for numerical aperture measurement. Now we will see the experiments related to analog link on fiber optic trainer. The experiment is setting up fiber optic analog link. Make the connection as given in the manual. For that, connect output of sine to input of F4 transmitter. Connect 1 meter fiber cable between F4 transmitter and F4 receiver through SMA connector. Now connect output of F4 receiver to input of AC amplifier and output of AC amplifier to input of low pass filter. Now connect first channel of CRO to input of sine wave and second channel of the CRO at the output of low pass filter. And keep the switch in analog link, that is in pressed condition. Now turn on the trainer. This is the output. The first channel is the input and second channel is the output. F4 transmitter port is given to adjust the intensity and F4 receiver to adjust the output of F4 receiver. AC amplifier will increase the amplitude intensity of the signal. Now we will see other experiments related to analog link. Study of bending loss. For this experiment, keep the setup as it was for analog link and measure the output voltage. This is the output voltage without any bend in the fiber optic cable. Now apply bend to the fiber optic cable with the help of mandrel provided, and we can see that the amplitude is decreasing. Now measure the output voltage after applying the bend in the fiber optic cable. We can see from the value of output we have obtained that when we apply the bend, the output voltage decreases. Thus we have studied the bending loss experiment. The other experiment is measurement of propagation loss. Keep the setup as it was for analog link. Measure the output voltage. Now change the 1 meter fiber optic cable with a different value of fiber optic such as 2 meter, 3 meter or 5 meter, and measure the corresponding output value. We can compare the value of the output when 1 meter was used and when we used 3 meter fiber optic cable, and we can see that as the length changes or increases, the output value decreases. Thus we have studied the propagation loss. Now we will see voice communication with the help of fiber optic. Remove the connection from sine and connect it to audio in of audio input block, and connect low pass filter output to audio out block. Now connect mic to mic in of audio input. And speaker to speaker out of audio output. As we change the port P4, the intensity will increase, and adjust on transmitter port, FO receiver port, AC amplifier port and audio output potentiometer to get the proper output at speaker out. Thus we have completed the voice communication using fiber optic. Now we will see the experiment of numerical aperture measurement using fiber optic trainer. For that we need NA zig and NA scale. Connect output of FO transmitter to input of NA zig. The scale on NA zig indicates the length, and the concentric circle on NA scale represents the width. As we change the length and the width will change, the intensity will change, and measure the width and length and put it in the formula given in the manual to calculate the numerical aperture. This way we have completed the experiment related to analog link on fiber optic trainer. Now we will see experiment related to digital link on fiber optic trainer ACT-12. Setting up digital link. Make sure that the switch SW2 is in digital link condition, that is unpressed position. Connect square output to input of FO transmitter. 1 meter fiber optic cable between transmitter and receiver. Connect output of FO receiver to input of comparator. Connect first channel of CRO to square wave output and second channel to comparator output and ground to ground. Now turn on the kit. This is the output. If you don't get the output at comparator out, then adjust the potentiometer given at comparator to get the output. You can also adjust potentiometer FO receiver and FO transmitter. Now we will see PC to PC communication on fiber optic trainer. For that we need two PC, separate PCs with hyperterminal installed in that. With the help of two numbers of RS-232 serial cable, follow the procedure given in the manual for PC to PC communication. This way we have completed experiment related to digital link in fiber optic trainer. Thus we have completed the demonstration of fiber optic trainer ACT-12. Thank you.